Namaskar, I am Dayan Gowde, Assistant Professor in Mathematics, Center for Distance Education, Shivaji University, Kolhapur. Today I will discuss solvable group from groups of the algebra of MSc first semester first. In solvable group, we come towards the derived subgroup of a group. Derived subgroup of a group. Let G be a group. Let G be a group. Define U is equal to AB, A inverse, B inverse. So that AB belongs to G. The subgroup generated by U, that is generated of U, is the class, the derived subgroup of G, and it is denoted by G dash. Repeat your definitions. Let G be a group. Define U, that is nothing but derived subgroup, is equal to AB, A inverse, B inverse, so that AB belongs to G. The subgroup generated by U, that is generation of U, is called the derived subgroup of G, and it is denoted by G dash. Point out, U is the set of commutator in G, that is derived subgroup of a group G is the set of commutator in G. Suppose that X belongs to G dash. This implies that X is equal to y1 multiply y2 multiply dot 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 yn, where n is finite integer and yi belongs to U for each I. G dash is also called commutator subgroup of G. G is abelian if and only if G dash is equal to singleton E. If and only if G dash is equal to singleton E. Next theorem. Let G be a group and let G dash be the derived subgroup of G. Then G dash is normal in G. Second, G by G dash is abelian. N is normal in G and G by N is abelian if and only if G dash is subgroup of N. For proof, we recall the definition of G dash is a subgroup of G only to prove that G dash is normal in G. We have to G dash is a subgroup of G by the definition of derived subgroup. We have to prove that it is sufficient to prove that G dash is normal in G. Let G belongs to G and X belongs to G dash. Case first, X belongs to G dash, therefore X is equal to AB, A inverse, B inverse. Then G inverse X, G is equal to G inverse AB, A inverse, B inverse. G is equal to G inverse AG, G inverse BG, G inverse A inverse G, G inverse B inverse G. This implies is equal to G inverse AG, G inverse BG, G inverse AG inverse, G inverse BG inverse. And this shows that G inverse belongs to commutator subgroup, derived subgroup, and therefore G inverse A belongs to G dash, and therefore G dash is normal in G. Case second, let x belongs to g dash and x is equal to y1 y2 dot yn by definition, where n is finite and yi belongs to u for each I, and hence g inverse xg being the finite product of elements of u is in g dash. Thus, for g belongs to g and x belongs to g dash, we get gx g inverse belongs to g dash, and hence g dash is normal subgroup of g. Therefore, g dash is normal subgroup of g. Now we have to prove that g dash is normal subgroup of g and g by g dash is well defined. Now to prove that g by g dash is abelian, let g dash b belongs to g by g dash. Then ab belongs to g dash a, g dash b, g dash b, g dash a inverse is equal to g dash ab, g dash ba inverse is equal to g dash ab, g dash ba bracket inverse is equal to g dash ab, g dash a inverse b inverse is equal to g dash ab, a inverse b inverse is equal to g dash, as ab, a inverse b inverse belongs to g dash. Therefore, this is identity of g by g dash. But this shows that g dash a, g dash b is equal to g dash b, g dash a. Therefore, g by g dash is abelian. Now we have to prove that n is normal in g by n is abelian if and only if g dash is subgroup of n. Only part, since g by n is abelian, therefore na into nb is equal to nb into na. This implies that NAB is equal to NBBA. NAB multiply NBA inverse is equal to N. NAB into NBA inverse is equal to N. NAB into N A inverse B inverse is equal to N. NAB A inverse B inverse is equal to N. Therefore, AB, A inverse, B inverse belongs to N. This shows that U is a subset of N. By the definition of subgroup generated by U, we get generation of U is a subset of N. This shows that G dash is a subset of N. We if part. Let suppose that n is normal subgroup of G and G dash is a subset of G. G dash is a subset of n. We have to prove that G by n is abelian. As G dash is subset of n, we get AB, A inverse, B inverse belongs to n. For all AB belongs to G. Thus, n AB, A inverse, B inverse is equal to n. N AB, N B A inverse is equal to n. Therefore, NA, NB, NB, NA inverse is equal to n. NA, NB is equal to NB, NA. This shows that NA, NB is equal to NB, NA, and hence G by n is abelian. Example on derived subgroup. For any n, the derived subgroup Sn dash of Sn is An. The derived subgroup of Sn dash of Sn is An. Case first, for n is equal to 1, 2. We know Sn dash is equal to singleton E and An is equal to singleton E. Therefore, Sn dash is equal to An for n greater than 2. Therefore, F is equal to order paired 1, 2 belongs to Sn and G is equal to 1, 2, 3 or belongs to Sn. Therefore, F inverse G inverse belongs to Sn dash derived subgroup, that is 1, 2, 1, 2, 3 G, F inverse 2, 1, G inverse 3, 2, 1 belongs to Sn dash, that is 1, 2, 1, 2, 3, 2, 1, 3, 2, 1. 1 goes to 2, 2 goes to 3, 3 goes to 1, 1 goes to 2, 2. Therefore, this is product of this product is 1, 2, 3 and 1, 2, 3 belongs to Sn dash, as Sn dash is normal subgroup of Sn for each n. Therefore, G belongs to Sn and X belongs to Sn dash. Hence, in particular, G 1, 2, 3 G inverse belongs to Sn. G 1, 2, 3 G inverse belongs to is equal to G. Now, F inverse G inverse is an even permutation for any F G belongs to Sn. We get Sn dash is a subset of An. By combining both the inclusion inclosure, we get Sn dash is equal to An, and this completes the solution. Next problem. Let G coordinate of G is equal to P prime. Then derived subgroup of G dash. G dash is equal to singletony. Similarly, coordinate of G is equal to P square. P is prime. Then G dash is equal to singletony. Since coordinate of G is equal to P, therefore G is abelian. Select any A belongs to G such that A is not equal to E. Then commutator of generator of A is a subgroup of G, and order of generator of A divides order of G by Lagrange's theorem. Hence, order of A divides P. As A is not equal to E, we get order of A is equal to order of generator of A is equal to P. Therefore, generator of A is equal to G. But thus G is cyclic and hence abelian. Therefore, G dash is equal to singletony. And so on completely. Solvable group. Solvable group. What is meant by solvable group? Let G be any group for any positive integer n. We define let G be any group for any positive integer n. We define the nth derived subgroup of G written as G raised to n as G1 is equal to G dash, G2 is equal to G1 dash, and G raised to n is equal to G raised to n minus 1 dash, where G dash denotes the derived subgroup of G, and this is solvable group.